Welcome to this explainer. Today, we're taking a ground-up architectural tour of a truly remarkable botanical marvel, the passion fruit vine. We're going to take what might normally seem like standard botanical facts and turn them into a bit of a sensory journey. We'll break down exactly how this magnificent plant is built, from the dirt all the way up to its incredible fruit. So if you've ever wondered how nature engineers such rapid growth and complex structures, well, you're definitely in the right place. Let's get into it. Okay, let's just jump right in by looking at the sheer mind-boggling scale of this thing. 5 to 10. That is how many meters long this vine can grow. Just picture that for a second. That's upwards of 30 feet. When we talk about a fast-growing climber here, we aren't just talking about a little houseplant creeping up a trellis. No way. We're looking at a massive, aggressive vine designed to completely dominate its space. And, this sheer volume of growth requires some absolutely incredible biological engineering, which brings us directly to the foundation of the plant itself. Section 1. Beneath the soil's surface. Let's look at the hidden foundation supporting this giant. Now, you might expect a plant that grows up to 10 meters long to have a massive, deep taproot anchoring it to the center of the earth, right? But surprisingly, despite its towering height, the vine relies on a really shallow root system. It spreads out right near the soil surface rather than digging deep. It's such a fascinating structural choice by nature. The plant basically prioritizes a wide, shallow net to rapidly capture surface nutrients and water, and that is exactly what fuels that explosive 5 to 10 meters of upward growth we just talked about. So because these roots are so shallow, having well-drained soil isn't just a preference. It's a strict, absolute biological requirement. If you're ever trying to cultivate this plant, or you just want to understand how it survives out in the wild, this is the golden rule. Because the root system is sitting right there near the surface, any standing water or poor drainage is going to immediately waterlog the plant. The roots literally need to breathe. Without well-drained soil, that massive 10-meter vine above ground, it simply collapses. It's this incredibly delicate balance, extreme vulnerability below ground to support absolute dominance above ground. Moving on to Section 2, Stems and Glossy Leaves. Let's explore the scaffolding above ground. This right here brilliantly illustrates the plant's life cycle in a single glance. The stem starts its life completely green and smooth, which is perfect for that rapid, flexible, fast-paced early growth. But it doesn't stay that way. As the plant evolves and needs to support more and more weight, that green, smooth stem actually transforms. It becomes a tough, woody stalk as it matures. It's basically a real-time structural upgrade. The plant literally builds its own rigid scaffolding to hold up the expanding canopy of leaves and eventually the heavy fruit. But, a woody stalk alone isn't quite enough to reach the top of the canopy. To achieve that massive 10-meter height, the stem employs a very specific, active mechanical method. It reaches out and uses curling tendrils to climb upward. Think of these tendrils like biological grappling hooks. They shoot out, sense their surroundings, and physically coil around any available structure, branches, trellises, fences, pulling the vine higher and higher into the sunlight. It's dynamic, active climbing happening right before our eyes. Now, let's take a look at the architectural blueprint of the foliage itself. We've got an alternate arrangement on the stem, which means the leaves stagger themselves to maximize their surface area without shading each other out. They're usually three-lobed, with distinct serrated edges, and they feature this beautiful, dark green, glossy finish. And that isn't just for show, by the way. That dark green, glossy surface is perfectly engineered to act as a highly efficient solar panel. It captures the maximum amount of sunlight to feed the rapid, explosive growth of the whole vine. It is literally nature's perfect energy-gathering design. And finally, Section 3, Fragrant Blooms and Fruit. Let's look at the ultimate payoff. So that 5 to 10 number returns, but this time we're talking centimeters. The large, super fragrant flowers that grow directly from the leaf axils measure a massive 5 to 10 centimeters in diameter. That is incredibly huge for a single bloom. Growing right out of the angle between the leaf and the stem, that's the leaf axil, these massive flowers act as a giant, fragrant billboard to attract pollinators. And they don't just rely on size and fragrance either. These highly fragrant blooms boast a beautiful, contrasting coloration of brilliant white and deep purple. It's a visually striking combination that serves as a highly visible landing pad for insects. It's almost alien in its complexity and beauty, but it serves a very specific, functional purpose to ensure the next and final stage of the vine's life cycle. Which brings us to the whole reason for all this effort, the juicy payoff. Depending on the specific variety, the fruit comes wrapped in a distinctly round or oval shape. The tough outer skin acts as a protective barrier and is usually either purple or yellow. But inside, well, that's where the real magic happens. A deeply juicy pulp loaded with many small black seeds. This fruit is the ultimate culmination of the plant's entire journey. It perfectly packages its seeds inside a delicious, nutrient-dense reward, ensuring they're carried off by animals and planted anew. So, as we wrap up our ground-up tour in this explainer, I want to leave you with something absolutely incredible to ponder. How exactly does such a shallow, delicate root system manage to support massive 10-meter woody vines, giant fragrant flowers, and heavy, juicy fruits? It's a fascinating paradox of sheer biological efficiency. The passion fruit vine manages to do all of that with a foundation that barely even scratches the surface of the earth. Thank you so much for joining me to uncover the anatomy of this incredible climber. Keep wondering, keep exploring, and I really hope this changes the way you look at the natural engineering all around us.